mechanism of adsorption. The situation existing at the surface of a liquid or a solid is different from that in the interior. For example, if we talk about a molecule, in the interior of a liquid is completely surrounded by other molecules on all sides, and hence the intermolecular forces of attraction are exerted equally in all the directions. We can see it. We talk about a liquid, then in a liquid there are different types of particles are present. Some particles are present on the surface of the liquid and some are present at the center of the liquid. So if we talk about the center molecule, then the center molecule is attracted by a different direction, but if we talk about the surface molecule, then the surface molecule are attracted only one direction. So we can see surrounded by the other molecule and all the sides, and hence the intermolecular forces of attraction are exerted equally in all the direction in case of center molecule. But if we talk about a surface molecule, that at the surface of a liquid is surrounded by larger number of molecules in the liquid phase and favors molecules in the vapor phase, that is in the space above the liquid surface. As a result, these molecule lines at the surface experience some net inward force of attraction which causes surface tension. So we can say that for the surface molecule, it causes surface tension. As a result, these molecule lines at the surface experience some net inward force of attraction which causes surface tension. The same condition is with solid, because solid, in case of solid, suppose if we talk about the nickel, then we can see that surface molecule, surface atom or surface metal has 3 valence. Similar inward force of attraction exists at the surface of the solid. Alternatively, in case of certain solids such as transition metals, there are unutilized free valencies at the surface. As we can see that it is a free valency. Free valencies because of the unbalanced inward force of attraction. We can see in both the cases, that solid and the liquid. Because of the unbalanced inward force of attraction or free valency at surface, liquid or solid have the property to attract and return the molecule of a gas or a dissolved substance onto their surface with which they come in contact. So we can say that in case of liquid, there is the inward force of attraction, and in case of solid, they have free valency. So both of the phases wants to stability, that's why they attract the molecule, and the phenomena of adsorption, that's free. So this is the reason. Now, second topic is adsorption and exothermic process. Adsorption and exothermic process. When adsorption takes place, the residual forces on the surface of the adsorbent decreases, because we can see that when adsorption takes place, then the molecule gets the stability, and due to the stability we can say that it releases some amount of energy, or in other words, surface energy decreases. This appears in the form of heat and it is known as heat of adsorption. So we can say that when adsorption takes place, the residual force on surface of the adsorbent decreases. In other words, surface energy decreases. This appears in the form of heat. This appears in the form of heat, which is called heat of adsorption. Hence, we can say that adsorption is an exothermic process. Hence, adsorption is invariably an exothermic process. That is, we can say that delta H adsorption is always negative. So adsorption is an exothermic process. Now the next topic is entropy change during adsorption and adsorption equilibrium. Entropy change during adsorption and adsorption equilibrium. As the molecule of the adsorbent are held on the surface of the solid or adsorbent, entropy decreases. That is, we can say that delta S is also negative. So delta S is equal to negative as delta G is equal to delta H minus D delta S. As we know, delta G is equal to delta H minus D delta S. Hence, for the process of the adsorption to occur, delta G must be negative as delta S is negative. Because delta S is negative, so we can say that negative multiplied by negative becomes positive. So the value of delta G will be positive. Hence, for the process of the adsorption to occur, delta G must be negative as delta S is negative. Delta G can be negative only if delta S is negative. If we want to come delta G is negative, it is only possible if delta S is negative. First condition is delta S is equal to negative. It is only possible when delta H negative. And when delta S is negative, we can say that delta H is greater than delta H can be negative, and we can say in that condition delta H is greater than P delta S is negative. This is true in the beginning. However, as the adsorption proceeds, delta H keeps on decreasing and P delta S keeps on increasing. Till ultimately delta H becomes equal to T delta S, so that delta G will be equal to 0. This state is called adsorption equilibrium. So when delta H is equal to T delta S, we can say in that condition it is known as adsorption equilibrium. Adsorption equilibrium. Now, differences between adsorption and absorption. Differences between adsorption and absorption. There is the two terms, adsorption and absorption. We can take a simple example that suppose if we have a closed container and in a closed container, water vapors are present, and silica gel and a piece of calcium anhydrous calcium chloride is present, then we can easily observe that the water vapor is absorbed on the surface of the silica gel like this. Because this phenomena occurs only on the surface, that's why we can say that it's a surface phenomena, and that surface phenomena is known as adsorption. So we can say adsorption on the. But if we talk about the anhydrous calcium chloride, the anhydrous calcium chloride absorb the water vapor in the bulk. So we can say that absorption into the interior. Into the interior means no absorption. So we can say the term absorption differs from the term absorption. In fact, that whereas the former refers to the attraction and retention of the molecule of a substance on the surface only, the latter involves passing of the substance through the surface into the bulk of the liquid or the solid. In other words, in absorption, the surface gets uniformly distributed throughout the liquid, or in some cases the adsorption and absorption both takes place simultaneously, and such processes are simply known as sorption. Both adsorption and absorption take place simultaneously. This process is known as sorption. Thus, in adsorption, whereas the concentration is different at the surface than in the bulk, and in absorption the concentration is same throughout. Moreover, whereas adsorption is fast in the beginning and then the rate decreases till equilibrium is attained. Absorption takes place at uniform speed, so we can tag the differences between absorption and adsorption as follows. Adsorption and absorption. First is the surface phenomena, and it is a bulk phenomena. And second, the concentration on the surface of adsorbent is different. Concentration on the surface of adsorbent is different from that in the bulk, and in this phenomena the concentration is same throughout the material.